Question number 20. Sound wave emitted from a point source uniformly travel in all directions at rate of 120 watt. So this is power. If no energy is lost as the sound travels outwards, calculate the intensity of sound wave. Okay, I. At a point 60 meter from the source. Okay, so R is 60 meter. Okay, so formula for sound intensity is intensity equals power over area. So because sound travels in all directions, so it is in the shape of spherical. Okay, so area for spherical shape is 4 pi r squared. So intensity equals power over 4 pi r squared. Substitute power 120 and then substitute r 60 meter squared. So the sound intensity equals 2.65 times 10 to the power of -3 and the unit is watt per meter squared. So the answer is B. Okay, the answer is B. 2.65 times 10 to the power of -3 watt per meter squared. And then question number 21. A bat is flying towards a wall. Okay, this is wall and this is a bat. Alright. Traveling or flying towards a wall. Okay, so bat produce frequency. Okay, produce sound. Okay, and the bat's flying at constant speed 50 meter per second. Okay, the bat emits a sound of 125 Hz. So this is frequency produced by the bat. Okay, and will be received by the wall. Okay, so because the bat moving towards the wall, so there is a Doppler effect. Okay, Doppler effect. So frequency received by the wall will be given by this formula. Okay, frequency received by wall from bat. Okay, so frequency received by the wall from bat finally will be reflected to the bat. Okay, will be reflected to the bat. So bat will experience the frequency received by the wall. Okay, first we have to calculate frequency received by wall from bat. Okay, received by wall from the bat. Okay, so because bat moving toward the wall, so you have to use formula frequency heard by the observer, FO equals V plus V of observer over V minus Vs times source of frequency. So now the observer is the wall. Okay, observer is the wall. Okay, for this time. Okay, so substitute V 340. Okay, V is speed of sound and VO is the speed of the observer. Observer is the wall. Wall is at rest, so the speed is 0. Okay, over 340 minus speed of sound. Okay, so sound come from the bat. So bat moving at 50 meter per second. And then time frequency source. Okay, source come from the bat. So frequency produced by the bat is 125. Okay, so frequency received by the wall from bat is 146.55 Hz. and then this frequency, will be reflected to the band. Okay, so now you have to calculate frequency received by band from reflection of the wall. Okay, from wall. Okay, frequency received by band from wall. Okay, so again, the band is moving toward the wall, so you have to use formula FO equals V plus VO over V minus Vs times Fs. Okay, so now the observer is the band. Okay, observer is the band. Substitute V is speed of sound, 340, and then VO is speed of the observer. Observer is the band now, so it is moving at speed 50 meter per second over V 340 minus Vs. Vs is the speed of the source. So source now is the wall. So the wall is at rest. So the speed of wall is 0. Times Fs. Fs is the frequency of the wall. Okay, wall receive 146.55. Okay, so frequency received by the band is 168.1 Hertz. So the answer is D. Okay, 168.2 Hertz. Okay, D. And then number 22. Okay, that one is number 21. And then proceed to number 22. Okay, 22. Figure 4A and B show displacement against time graph and displacement against distance graph. Okay, for the transverse wave, determine the velocity of the wave. Okay, from the graph of displacement against time, okay, this one, okay, you can determine, okay, you can extract from this graph that the period of this wave is 40 millisecond. Okay, so this is the period. Period equals 40 millisecond because unit for t is millisecond in this graph. And then from graph of displacement against distance, you can determine lambda. Okay, this is lambda. Okay, lambda from this graph is 4 millimeter. Okay, then you can calculate velocity of the wave. Okay, velocity of the wave is given by V equals F lambda. Since F equals 1 over T, so V equals lambda over T. So substitute lambda, okay, 4 millimeter. So you have to convert to meter, and then substitute period. Period is 40 millisecond. So you have to convert to second. Okay, so times 10 to the power of -3. And then V is 0.1. Okay, 0.1 meter per second. So the answer is B. Okay. And then number 23. An organ pipe of length 33 cm is open at one end and closed at the other. Calculate the frequency of the first overtone. Okay, so this is closed pipe. Okay, this is closed pipe. Open at one end and close at the other. That means this is closed pipe. So for closed pipe, only odd harmonic occur. Okay, only odd harmonic occur. Okay, so you have to calculate the frequency of the first overtone. Okay, so whenever you want to substitute n in the formula, maybe you can or you want to draw standing wave and closed part. Okay, so you have to relate with harmonic. Okay, you have to relate with harmonic, not overtone. So let us find out first overtone is equivalent to how many harmonic. Alright, so fundamental mode is the first harmonic. Fundamental mode is the first harmonic. Okay, after fundamental mode is the first overtone. Okay, first overtone is equivalent to third harmonic. Okay, second harmonic does not exist for closed pipe. Okay, so this one is third harmonic. N equals 3. Okay, so you can use formula of frequency for closed pipe, but this one I want to use drawing of standing wave. Okay, so third harmonic, that means we have 3 times of first harmonic. Okay, 1, 2 and 3. Okay, so and then this is the reflected wave 1, 2, 3. Okay, so this is the length of the pipe L, and relate how many lambda in this wave pattern, waveform. So we have half plus 1 over 4. So it is equals 3 over 4 lambda. 3 lambda over 4. So lambda equals 4L over 3. Lambda equals 4L over 3. And then you can calculate frequency of the first overtone by using formula V equals F lambda. So lambda equals 4L over 3. Substitute V 330. F is the unknown that you have to find. And then substitute length. Length is 33 centimeter. You must convert to meter. Divide with 3. So the frequency equals 750 Hertz. Okay, so the answer is C, 750 Hertz. And then number 25. Okay, number 25. Okay, sorry, number 24. Number 24, when a load of 16 kg is hung vertically at the end of 5 meter long wire, the extension produced in the wire is 0.38 cm. So this is the elongation. Okay, if the and 5 meter long wire is the L naught. Okay, if the cross section area of the wire is 1 millimeter squared, so this is the area. Determine the Young modulus of the wire. Okay, so formula for Young modulus is given by stress over strain, where stress equals F over A and strain equals elongation over L naught. So we have formula for Young modulus is FL over AE. FL naught over AE. Okay, so F you can determine from concept of Newton's law. Okay, so this is the wire and then this is the load. Alright, so force acting on this load is the tension and weight vertically downward. So this load at equilibrium. So net force Y equals 0. So T minus W equals 0. So T equals W. Okay, where W equals mass times gravity. Substitute mass 16 and G 9.81. So we have T 156.96. Okay, so this is the tension of the wire. Okay, the tension of the wire actually is the force on the wire. So now you can substitute all the values in the formula of Young modulus. Alright, 156.96 times original length of the wire is 5 meter, and then the cross-sectional area is 1 millimeter squared. So you have to convert to meter squared. Okay, you have to convert to meter squared. So okay, it is like this. 1 millimeter equals 10 to the power of negative 3 meter. So 1 millimeter squared equals, okay, 10 to the power of negative 3 meter squared. So equals 10 to the power of negative 6 meter squared. Okay. So now you can substitute cross-sectional area of the wire is 1 times 10 to the power of negative 6, okay, in unit meter squared, and the elongation is 0.38 cm. So convert to meter. So 0.38 times 10 to the power of negative 2. Okay, so the Young modulus equals 2.07 times 10 to the power of 11. Okay, and the unit is Newton per meter square. Okay, so number 24 is A. Okay, number 24 is A. Times 10 to the power of 11. Okay, be careful whenever you want to substitute value. Make sure the value is in SI unit. Okay, then we can proceed to number 25. A copper rod of radius 0.5 cm and length 10 cm is in thermal contact with brass rod of the same dimension. That means the brass rod have the same radius as the copper and the length the same as the copper. Okay, the end of the copper rod is held at 150 degrees Celsius, while the other end of brass rod is placed in an ice bath. Okay, that means at temperature 0 degrees Celsius. When the system is in thermal equilibrium, find the temperature at the copper brass interface. Okay. Okay, so this is the rod of, okay, okay, it is like this. Okay, so this is copper rod connected with brass rod. Okay, their length are the same and the radius the same. Alright, so temperature at the end of the copper rod is 150 degrees Celsius and temperature at the end of the brass rod is 0 degrees Celsius. Okay, so you have to find temperature at border of copper and brass rod. Okay, copper brass interface. Okay, so they are in thermal contact. Okay, they are in thermal contact. So rate of heat transfer of copper is equals rate of heat transfer for brass. dq dt copper equals dq over dt brass. Okay, where formula for dq dt is negative Ka dt over x. Okay, where K here is K for copper, area for copper, and dt is temperature, change of temperature for copper, and length of copper. And then this one, negative K of brass times area of brass, change of temperature of brass over length of brass. Alright, so copper and brass have same dimension. That means area copper equals area brass. So you can cancel them. And then length of copper equals length of brass. You can cancel them as well. And you can cancel the negative sign. Okay, so it is easier now to substitute values of Kc. Kc is 390 and change of temperature of copper is T minus 150. So heat is transferred from higher temperature to lower temperature. So temperature final for copper is T and temperature initial for copper is 150. So T final minus T initial will be T minus 150. Okay. And then substitute thermal conductivity of brass. So it is 110. Okay. And then change of temperature for brass is 0 minus T. Okay, 0 minus T. So the rest is mathematics. Okay, the rest is mathematics. Okay. You can find T. Okay, so T equals 117 degrees Celsius. So the answer is C. Alright, and then proceed to number 26. A 4 meter long wire expand 0.12 cm in length. Okay, that means this one is delta L. For a rise of temperature of 50 degrees Celsius. So this one is delta T. Find the coefficient of linear expansion for this material, alpha. Okay, so you can use formula alpha. Okay, coefficient of linear expansion equals to change of length over original length times change of temperature. Okay, so substitute delta L. Delta L is 0.12 cm, so you have to convert to meter and divide with L naught. L naught is 4 meter. Okay, 4 meter. L naught is 4 meter. Alright, and then times delta T. Delta T is 50. Okay, so alpha equals 6 times 10 to the power of negative 6 per Kelvin. Okay, this one, or per degree Celsius. Okay, so this one is number 26. Okay, and then number 27. Okay, number 27. Calculate translational kinetic energy of a molecule nitrogen gas at 300 Kelvin. So the formula is K translational equals 3 over 2 KT. Okay, substitute K. K is the constant. Okay, you can check the value from list of constant value. Okay, it is 1.38 times 10 to the power of negative 23 temperature is 300 Kelvin. Okay, temperature must be in unit Kelvin. Okay, must be in SI unit. So translational kinetic energy equals 6.21 times 10 to the power of negative 21 joule. So the answer is A. Alright, and then number 28, the pressure of an ideal gas in a vessel of fixed volume is P. If the gas in the vessel is heated so that the root mean square speed of its molecules is increased 3 times of its initial value, what is the final pressure of the gas? Okay, so formula for V Rms is V Rms equals surd 3 pressure over rho. Okay. Okay, so we want to find P. So let P be the subject. Okay, so arrange this equation. Let us eliminate this surd. So square both equation. V Rms equals 3P over rho. So P, pressure, equals density rho V Rms squared. Okay, so this one is for initial condition. Okay, initial condition, and then state that V Rms final is increased 3 times. So that means V Rms final equals 3 V Rms initial. Okay, alright. So V Rms final. Okay, final V Rms final. Maybe we can write V Rms prime. Okay, so this one is for final. V Rms prime equals surd 3 final pressure P over rho. Okay, rho is density. Density is still the same. Okay, density is constant. Alright, and then eliminate the surd, so become V Rms prime squared equals 3 pressure prime over rho. So pressure prime, or the new P, or the final P, equals rho V Rms prime squared. Right? Okay, and then relate with this one. Okay, V Rms equals V Rms prime equals 3 V Rms. So this one become pressure prime, okay, equals rho 3 V Rms squared. Okay, so simplify this one. So it become 9 rho V Rms squared. Alright, where V Rms squared is P. Okay, V Rms squared is P. So P prime equals 9P. Okay, so the answer is D. Okay, the answer is D. Alright. Then number 29. Number 29. Okay. 2 moles of ideal monoatomic gas, initial temperature 130 degree, expand and in the process absorb 1500 joule of heat. That means Q is positive. Okay, absorb heat, so Q is positive. Alright, and do 2000 joule of work. So W is positive as well. Okay, so W is positive 2000 joule. Okay, determine the change in internal energy, delta U. So you may use Q equals delta U plus W Okay, substitute Q. Q is positive 1500. Delta U is the unknown that you have to find. And W is positive 2000. So delta U equals negative 500 joule. So the answer is B. Okay, last question, number 30. Okay, 3 moles of an ideal gas are heated at constant pressure from T 25 degrees Celsius to T 74 degrees Celsius. Calculate the work done by the gas. So this is isobaric process. Okay, because it occurs at constant pressure. So work done for isobaric process is given by W equals PdV. Okay, so for ideal gas, PV equals nRT. Okay, so if P delta V or PdV, it will be equal nR delta T. So you can substitute W equals nR delta T, where delta T is T final minus T initial, T2 minus T1. So substitute N is the number of moles, is 3, and substitute R, it is 8.31, and T2 is 74, and T1 is 25 degrees Celsius. So work done equals 1221.57 joule. So the answer is A. Thank you, class. All the best.